Yes, dear students, now I am going to solve some questions which have been asked in different competitive exam. In question number 1, photoelectric anode voltage of photocell kept fixed. Remember what happens here: cathode, anode, fixed cathode, radiation are allowed to fall. So this anode voltage kept fixed. But the wavelength of radiation is changed, increased. Anode voltage of photocell kept fixed. The wavelength of light falling on cathode is gradually changed, not increased. Increase नहीं कहा, दोस्तों increase तो यहाँ होगा change. Gradually, the plate current I of photocell will vary. Option A, B, C, D. Photoelectric current. है भाई? तो photoelectric current will vary according to this graph or this. You know, for every metal there exists a lowest frequency below which there is no radiation. That is called cutoff frequency. So H nu 0. W is equal to H nu 0. If adenokin energy is equal to H nu minus H nu 0 or Hc upon lambda minus Hc upon lambda 0. If lambda 0 if we think this graph on this lambda, this energy will become less than this. So no electron will be added as we increase. So this is wrong. As lambda increases, if this lambda become more than this, then energy required to emit the electron will keep on decreasing and emission will stop. It is possible here. So here it is showing that on increasing lambda, current increases number of photoelectrons, which is wrong. By electron are emitted when energy of radiation falling on photocathode is more than the work function. This represents work function. It is the energy K. So if lambda increases, this energy decreases. So these two are not possible here. At shorter wavelength, electrons are emitted, and as we increase wavelength, at large wavelength current becomes 0. So this is possible graph here. This is also not, because increase decrease not possible. So this C part is there. So here the option C is correct. Now there is another question here. Options are not written here. ये A, B, C radiation है. Here in this figure, is this visible or not? Yes. Anode potential, photoelectric current. For 3 radiations are shown. मैं दोबारा बनाते हैं यहाँ पर. वो देखिए मेरा नाम. It is for A, for B, and for C. A, B, C. So there are, this is a node potential here. and here is current I. तो ऑप्शन हियर आर गिवन कि इनमें कौन ट्रू होगा फॉर फोटो एमिशन. ऑप्शन ए एफ ए इक्वल टू एफ बी एंड आई ए नॉट इक्वल टू आई बी. बी ऑप्शन एफ ए इक्वल टू एफ सी एंड IA equal to IC. C option FA equal to FB and IA equal to IB. D option FB equal to FC and IB equal to IC. I means intensity of radiation or F means frequency of radiation. Sorry, this is graph like this. So frequency give the kind energy, maximum kind energy, and maximum kind energy is measured by cutoff potential and negative anode potential at which photoelectric current becomes zero is called cutoff potential. So for same frequency cutoff potential same, तो here FA equal to FB तो हो गया. Now this saturation current will be same at same frequency. So here FA equal to FB, IA is not equal to IBS. It is true here, but what is this? FA not equal to FC, IA equal to, ये भी गलत हो गया. FA equal to FB तो है, but IA is not equal to IB, इसलिए wrong हो गया. And then FA equal to FC तो है ही नहीं क्योंकि इसका कटऑफ पोटेंशियल हाई है, तो इसलिए गलत हो गया. IB बराबर IC तो है, लेकिन दिस फर्स्ट वन डज नॉट मैच. सो विच करेक्ट? दिस ऑप्शन इज करेक्ट. तो दिस वे यू हैव टू लर्न द थिंग्स. सो बाय डूइंग द प्रॉब्लम्स, व्हेन यू सॉल्व प्रॉब्लम you apply your brain and you get the things learned by heart. Now I do some more questions for you here. Please like the video, share the video, and ask your friend to subscribe. And if you have not subscribed, you please also subscribe. Now there is a question here. In a photoelectric effect, the stoic potential R3V0 and V0 for wavelength V0, 3V0 and V0 are stoic potential when a radiation of wavelength lambda and 2 lambda are incident. Larger the wavelength, smaller the frequency of radiation. तो थ्रेशोल्ड वेवलेंथ यानी कि लैम्बडा 0 क्या होगा? ऑप्शंस आर गिवन हियर. ऑप्शन ए इज 4 lambda by 3. ऑप्शन बी 4 lambda. ऑप्शन सी 6 lambda. ऑप्शन डी 8 lambda. थ्रेशोल्ड पोटेंशियल और कटऑफ पोटेंशियल 4 lambda is 3V0, 4 lambda V0. So what is threshold potential? Threshold wavelength. We know kinetic energy equal to hc upon lambda minus hc upon lambda 0, and k is measured by EV. So when wavelength lambda is 3v0, 3ev0 equal to hc upon lambda or minus hc upon lambda 0. Now for 2 lambda it is v0. So E into v0 is equal to hc upon lambda 2 lambda minus hc upon lambda 0. Now how will you solve this for lambda 0? It is very simple. EV0 is this. Put it here. Putting this here, you get 3 bracket hc upon lambda 2 lambda or minus hc upon lambda 0 is equal to hc upon lambda minus hc upon lambda 0. You need lambda 0 in terms of lambda. These hc will get cancelled. So it is 3 upon 2 lambda minus 3 upon lambda 0, 1 upon lambda minus 1 upon lambda 0. 3 upon 2 lambda minus 1 upon lambda is equal to 3 upon lambda 0 minus 1 upon lambda 0. LCM 2 lambda. 3 minus 2 is equal to 2 upon lambda 0. And problem is solved now. How? 1 upon 2 lambda equal to 2 upon lambda 0. So lambda 0 is equal to 4 lambda. B answer is correct. So this is simply a practice which you need, and dear friends, solve more and more questions until unless you do a good practice. I know many students of mine, a girl was little above average. She did coaching but could not get selected. His father took leave, sit at home and asked the girl to sit with him and not to go out and ask him. The father asked the girl to solve problem only, not to learn that chapter, and got selected KGMC. तो जब तक आप नहीं करिए, नीट में क्वेश्चन है ये. Now there is another question here. The work function of metal substance W 4 electron volt. The longest wavelength of light that can cause photo electron emission from the substance is approximately. Option है 540 नैनोमीटर, B है 400 नैनोमीटर, and C 310 nanometer, and D option is there 220 nanometer. Work function of the metal is 4 electron volt. The longest wavelength, we know W is equal to hc upon lambda 0. Dear friend, please, some shortcuts are required. I have used in one question hc. Value of hc has been solved equal to 1240 electron volt nanometer. So if we put the work function in electron volt and hc is this, the lambda will be obtained in nanometer. So 4 is equal to 1240 upon lambda 0. So lambda 0 is equal to 310 nanometer. 310 nanometer direct. But remember, you have to remember this. Okay, Hc in electron volt nanometer is 1240. So please, तो answer C answer. Longest wave. If is we increase wavelength, further emission will not take place. ये मतलब है यहाँ पर. Longest the wavelength, lesser the energy of photon. Now next question here. Again, actually they mix question together. A question of 1 mark involve knowledge of 2 or 3 chapters. Here is the question like that. The work function of photosensitive material W 6.2 electron volt and wavelength of incident radiation. The wavelength of incident radiation for which stopping potential V0 is 5 volt lies, option A, lies in the region of UV rays, UV ray region. B, visible region. Wavelength of radiation falling on photocathode for which cutoff potential 5 volt per function this. And C option infrared, and D option X-rays. So now please learn the spectrum of EM waves. I have taught EM waves. Sorry, ये क्या हो गया सर? I hope you remember the wavelength range visible light 4000 angstrom to 7000 angstrom X-ray, maximum to 100 angstrom. Infrared is more than 7000. Ultraviolet from 100 angstrom to certain 200 angstrom तक. नहीं, sorry, it comes from 100 to 4000 angstrom. So how to find wavelength? Again, the question. Kinetic energy equal to energy of photon plus minus work done. So energy of photon will be K plus W. 5 volt is the stored potential. So K maximum will be 5 electron volt. And work function itself is 6.2 electron volt. So energy of photon which should fall on that. Sum of these two indicate 11.2 electron volt. Just now I told you Hc upon lambda equal to E हो गया यो, and Hc upon lambda ये Hc 1240 upon lambda equal to 11.2. So what is lambda from here? That will come out in nanometer. How much? Lambda equal to 1240 1.2. If I take it as 11, 0.2 छोड़ दूँ, 1 जा 12, 11 1 जा 11, 3, 30, 22 7 कुछ आएगा नैनोमीटर और 1120 एंगस्ट्रोम। तो these are this to this is of ultraviolet. So this option is correct here. I hope you are getting me. This question has been asked in All India PMT. This question has been asked in All India PMT. Now I hope you can do more and more questions yourself. I have given idea how to solve problem, and now I think it is sufficient. Let me finish syllabus further. In next video I will start atomic physics. Thank you. But if you like my video, please like the video, share the video, and ask your friend to